So here we are with dynamics in fall of 2021, and this is homework 3. And here's problem 1, where we have at halftime at a U-Hart soccer game match, Howie the Hawk is throwing souvenir balls to spectators in the upper seats with a velocity of VO starting out. Howie releases the ball at 6 feet above the ground at an angle of 35 degrees with horizontal, and he is 25 feet away from the front of the stands. That front edge of the stand is only like 3 feet high, and then this angle of the stands is 25 degrees, and the the beginning of this upper section that he's aiming towards is like 30 feet as measured along the slope, and 15 feet from that point to the back edge. So he wants to land in between B and C, and we want to find the range, and we want to do it in miles per hour. So we have some kind of like a feel for how much that is. All right, so I've written out the problem here, and my hair is shedding. So let's take a look, and I'm going to take a peekaboo at my previous solutions so I can remember as I'm going through here how I did this. All right, so one of the very first things we probably want to do is try to figure out some geometry, or even before that, kind of decide where is 0, where is the reference, and I think I decided to make it right here at the release point. You could also have made it down convenient, could have been down right there as well, and then y0 would have been A, but I think I decided for whatever reason to when I wrote out another version of this problem, I started right up there. I'll say that x0 is 0 and y0 is 0. So I got to figure out what the coordinates of this point are going to be and the coordinates of that point. So this is we'll say that that's like we'll call this A right there, right? And this is B and this is C. So this is where A is going to be. So where is B? Okay, well, in the x direction, let's say we'll go xb is going to be it's going to be B, right? So it's going to be the 25 feet right there, right? 25 feet from right here to right here, and now we have to figure out what the horizontal distance is to B. So that's going to be plus my D of 30 feet times the cosine of beta, or 25 degrees. Did I do that right? Yeah, I think so. So let me see where abouts that is. 25, 30, and 25 cosine of that times, and add that. So I say that's going to be 52.19 feet. All right. And so y, you got to be a little bit careful here with yb. Or actually have to come down, right? So it's really going to be A minus C right there, right? So we're going to start out with actually, yeah, I just want to be careful here. I think we have to say, what did I decide to do? Yeah. Let's start out with how high this goes right here, and then we're going to subtract out the difference between these two right there. So that would mean we have C, which is 3 feet, and then we're going to subtract out 6 feet, right? So that's -3 here. And then we're going to add to that D, 30, times the sine of 25. Let's see, did I do that correctly? I think so, and I didn't use my space very wisely. So it's going to be 30 times the sine of 25, and then I'm going to subtract out 3 from it. So it's going to be 9.679 feet. So that's how much higher this is than that. It doesn't quite drawn that way to scale, huh? And I have a spreadsheet that I have for this problem too, so I can double check that there. And yes, I got it right. Cool, yay. All right, so this is to find C. That's just pretty much the same thing. Just now 25 feet plus, we're going to add these two, D plus E, so that's 45 feet times the cosine of 25. So I get 65.78 feet. And then YC, that's going to be the same thing. So it's just going to be minus 3 right there, plus our 45 times the sine of 25. And that's going to be 45, 25 sine times 3 minus be 16.02 feet. And let me double check my spreadsheet there. Yeah, got it. Okay. So that's just like some preliminary stuff to try to figure out, okay, where is it going to land from that, right? So the basic idea in projectile motion problems is that time is the same for both the x and the y direction. In the x direction, it's a constant velocity problem. In the y direction, it's a constant acceleration problem with acceleration pointing downwards. And we have US units, so we're using 32.2 feet per second squared for our gravity. And so we start out with, in the x direction, I accidentally bought a bunch of the 0.5 versions of these pencils when I thought it was the 0.9, and I kind of like misplaced a bunch of my 0.9, so you don't care. It's a stupid thing to start talking about. Okay, so we have VO in the x direction times t. Something we should note somewhere around here, that VOX is going to be VO times the cosine of 35 degrees. And that VOY is VO times the sine of 35 degrees. That's a good thing to do. All right, so here in the x direction, and we know that x is 0 here, so we can solve for time, and that's just going to be x over VOX. Right, and we're going to use that the position right here is going to be the original position plus VOY times time minus 1/2 g t squared. And we can substitute time in for there, so that we end up with y is equal to, and by the way, we'll just go ahead and say that that's 0. So we have VOY times time, but that's times x. So let's get this right over there. There's VOX right there, minus 1/2. Do I put the g in here? Sure, I'll put it at 32.2. Right? And that's going to be x squared divided by VOX squared. Now we can go ahead and substitute these two things back into there. This is very common for us to do, and we note that we have VO divided by VO, and we have sine over cosine. We can go ahead and do that in one step if you want to, or we could write it out again. But we have sine over cosine, and we know that's going to be tangent. So we'll go tan of 35. And we note that that goes away right there, right? And then that's times x. And I didn't leave enough room right here between my little line. Let me rewrite all that out here. Don't want to try to cram stuff in. And I didn't really do a good job of erasing it all the way. Okay. So we have y is equal to substituting in VO over VO sine of 35 over cosine of 35 x. Don't forget the x. The x is still there. X, and then minus 1/2 32.2, and then we're going to have x squared over VO squared, right, times cosine squared of 35. And that comes to, this becomes the tangent of 35, sine over cosine. So I think this is the point in which I decide to go ahead and oh yeah, and these cancel out right there. It's going to be easy for me now to put values in there, right? So the tangent of 35 is 0.7002 x, and then minus, now I can go ahead and write in here 32.2 divided by 2 and divided by the cosine 35 squared divided, I get 23.99. And that's going to be x squared over VO squared. And we note that we have VO is all by itself. So let's solve for that. VO, right? So we're going to have y minus 0.7002x. It's going to be divided by, oh, I think I got this backwards. My bad. I have to be careful. I'm trying to do this in one step. Maybe I should do it in multiple steps. But you can see that this is going to be true, right? We're going to have 23.99 x squared, and that's going to be divided by y minus 0.7002 x. And that's going to be the square root of that, right? Just did a little bit of algebra. All right, so now I can go ahead and put in this first one right there. So at B, xb is equal to 52.19, and feet, dang, yb is going to be equal to 9.679 feet. So if I put that in, I'm going to have VO at B, I guess. It's going to be the square root of 23.99 52.19 squared divided by 9.679, yeah, minus 0.7002 times 52.19. And that's going to be equal to 52.19 squared, multiply it by that 23.99, 9.679, and we hope that this is going to be smaller than that, right? That's an important thing for us. And then 0.7002, 52. Where did I go? 119. Let me write that in there. Speaking and writing and thinking at the same time. 19 times, and we're going to subtract that out. Ooh, that's not good. All right, so let me see. I did something wrong here. Let me pause. Oh, yeah, I got this backwards right there. shoot, 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 because that's negative. This flips around. Should have just read off of what I have written over there in the other thing, but no. And I'm going to try to think my way through this thing. 0.7002x minus y. And so this becomes right here. Yes. 0.7002 times our 52.19 and then minus our 9.679. Let's see if I get this right this time. And then 0.7002, 52.19 times, and then 9.679 minus, divide, square root, and I don't think I got that right. I'm not feeling good about that. All right, let me see here. Let me do this again. Maybe I gotta pause the recording. Yeah, I just plugged it into the calculator wrong, like everything. So this is 49.3132 feet per second, and we can multiply by 3,600. That's seconds per hour, and then divide by 5,280. That's feet per miles, and we're going to get 33.63 miles per hour. And then put it in the other one. I didn't arrange this as neatly as I'd like. At A, where XA is equal to 65.78 feet, and Y, I said A, I didn't mean A, I meant C. C, that's the point we're trying to go to, C. And that's 16.02 feet. So we'd find that VO at C is going to be the square root of 23.99 times 65.78 squared divided by 0.7002 and 65.78 minus 16.02. Gonna have just enough paper, I guess. Should have scrunched it up a little bit more near the top. Plan this out some, but oh well. 65.78 squared times that 23.99, and I have 0.7002, 65.78 times, subtract out 16.02, divide and square root. Do I get 58? Yes, I get 58.78 feet per second, and I'm going to multiply by 3,600 and divide by 5,280, and I get 40.08 miles per hour, and then I'll write the thing out. Answers. It's going to be, did I write this out? I guess I did. VO Did I ask for velocity's value of the speed? Yeah, I think I'm okay. Is going to be equal to 33.6 to 40.1 miles per hour. And I think that's good enough. That's the range of initial velocities that I'll need to be able to hit it between this point and that point. All right, next up.